I'm going to show you one of the ways to create the casting, which is this part of the gear puller. Let's have a look at the drawing. This is the top view. This is the front view. We'll have to discuss some of the sizes because not all of the information is clearly given and we have to make some educated guesses. So we know that the distance across here is 20, and if you have a look, approximately halfway is about the same distance here. So we're going to call this distance here 5 on this side, so added together makes it 30 by 30 square. Now we're going to draw this as two separate parts. One is the central hub, and the other part is these two arms. When you create the central hub, when we extrude it, we have to make it have a slight taper, which is what this is here. There's a slight taper on the end of the arms. We don't know what that is, so we're going to make a guess at around about 2 millimeters or so. The diameter of this hole is not given, but we can make an educated guess based around the fact that the pin is a diameter 6, and that is where the pin goes through to hold the two legs. Next is a 16 millimeter by 2 metric thread. The diameter of that is not given. If you were in a workshop, you would drill a hole 14 millimeters, which would allow the die, which is the tool used to cut a thread, to actually cut into the material to make the thread. But in Inventor we need to draw it the same size. So the size of the hole that we will cut will be 16 millimeters in diameter. In order to draw this slot, we need this information here, which is the fact that the total length of the slot is 32. And over here, this information tells us that the diameter across here is 7. So if you were to drill a hole first and then cut in, the diameter of the hole would be 7 millimeters. Now what that means is that the radius, so from the center line out, is 3.5 millimeters. When we calculate the length of the arms, we need to take into account the total length of 175. So if you were to divide that in half, that would give us a length of 87.5. If we deduct 15, which is half of the 30, it gives us a length from that top view of 72.5 millimeters in total. So let's have a go at drawing this in CAD. We're going to start a new metric part, and I'm going to draw a sketch on the XY plane. I'm going to start with a 2-point center square or rectangle, starting at 0, 0 with a green dot, drag it out, and I'm going to type 30, tab 30, enter. And that gives me the square that I'm after. Right-click, finish the sketch, and right-click, extrude. When we extrude, we want the length to be 30 millimeters. We didn't discuss that, but the height of this is 25, and it is about 5 millimeters taller than the size of the arms. But before we complete the extrusion, we need to go to the More tab, and we'll change the taper to approximately 5 degrees, and that gives us the angle that we're after. So if you rotate the block around and start a new sketch on this top surface, we can insert a 16 millimeter diameter hole. If I angle it a little bit so we can see what's going on, we'll finish that sketch, extrude, cut that section, and that goes all the way through. Now we might as well put a thread on that. If I select there, it will automatically come up with a 16 by 2 thread because the hole is 16, and we can use the cool orange add-in to change that to an actual thread. Previously it was just a visual thread, now it represents an actual thread. So I'm going to press and hold my shift on the keyboard, press and hold the center mouse, and if I move the mouse I can rotate this around to view the bottom. Now I can use the view cube, but the shift and center mouse key is a good tool to use. I'm going to draw a sketch on the bottom. Pan it across with my center mouse button, This time I'm going to use a normal rectangle or a regular rectangle, and I'm just going to click and drag my mouse across, and I'm going to draw and click far enough into the part so that I skip that top edge. So if I rotate it around, I'm talking about this top edge here. And so when this extrudes up, it's not going to extrude into space, if that makes sense. Right click OK. So if I just turn that around again, we can see this view. Now we need to put a few dimensions on for this. First of all, I'm going to dimension from this outer edge, which is the one on the top, to here. Try again, here and here. And the distance is 5. Then the distance of this line is 20. And the length that we worked out was 72.5, I think. All right, now I can insert a 7mm hole or circle, and the distance, right click, I'll just put a line in first and we'll dimension that in a minute. Bring that across to there, hook it in with that automatic constraint through the center, so that little dotted line that was going on there. That wasn't horizontal, so I'll make it horizontal. Okay, now that was interesting because the center point of this has moved. So I definitely want to lock that back in so it's on that same line. So I just used the horizontal constraint and selected both the center circles, the center points there, so that they're on the same line. I'll trim this little bit that is not needed anymore. Add in a dimension from the center out to this line here, which was, I forget what we said that was, 28.5, I think. Okay. Now, I do want those two to be the same length, so I'm going to make them collinear. So I'll select this one, then that one, and that makes them the same length. Wondering why that dimension has gone. I'm not sure whether I did that correctly. Okay. Let's drag and move that whole thing over a little bit so that it's in there. Now, see what's going on here? We need to make that tangent. So if I make that and that tangent, that and that tangent, that's tidied that up a lot more. Alright, so when I put this 72.5 on before, I obviously missed that, and that was what was causing those problems there. I'm going to now put a construction line lined up with the center of the hub. It doesn't matter how long it is, doesn't matter if it goes all the way through. Because it's a construction line, it won't be part of the project. I don't have to delete it later, but it does line up with 0 because I need to have a line in which to mirror this object. So I'm going to select all of these parts here. Now I could click and press the shift button and select every single bit, but if I select it in a window, it is sometimes a bit quicker. If I just demonstrate something though, if I go from the right, pressing and holding the mouse, and go to the left, it selects all of this, but it also selects these two lines here, which I don't want to copy or mirror. So I'm going to just undo that by clicking. Whereas if I come over from the left and I just select that stuff there, everything that is completely inside the window is selected. So now I can come up to mirror, select that mirror line there, go apply, and done. So I've now mirrored across that center line that sketch. And now I can right click and finish the sketch and right click extrude. When I select both of these, I'll change the distance. See how it's red? That is Inventor assuming that I want to cut a little groove in there. I don't want to. I need to make sure that I definitely select the solid object and say OK. And there's the little part there. Now I can put a 3D model. I can put a chamfer on this edge here, and we can do an uneven chamfer. So I can make distance 1, 2 millimeters and the next distance 5. I select that. I don't like that one, I'll just flip it, and that's what we're after. So that's the sort of angle that we're after. Now I have found in 2019 that I actually can't select all 4 corners. You have to do it one at a time, which is slightly irritating, but that's just how it is at the moment. And I'm going to put a 1 mil little fillet on that edge there, and you can put a little fillet in here as well if you want to. The good thing about the fillets though is that you can select all of them at once and just have one fillet here in the browser. Now to do the slight chamfer on this edge here, we have to select this top edge, and I'll make this number here 25 because it needs to go the full length. Alright, so if you can see what's going on there, let's move that over. There's our taper that goes to the full length. So go to that. Actually, it hasn't gone full length, and I'll tell you why that's happened. When I did this extrusion, it automatically went to 30. So let's go back to that one, and I'll just change that back to 25 because there's supposed to be a little gap here. Alright, we go back to that picture. See how there's supposed to be about a 5 mil gap there? So I just went back, double clicked and modified that. Now the taper is correct. And again, you have to do, sorry, it's a chamfer, not a taper, incorrect terminology. You now have to do each one of them as an individual. Last thing that you need to do is to start a sketch here and to insert the 6 millimeter hole. And if you saw that, there was an automatic constraint. When I started it, that little dotted line means that it's exactly central. We know from the drawing that from the bottom point to there, the distance is 15. And we can cut that out, finish sketch, sorry, and then extrude. So we'll go extrude cut, select the circle. Whoops, I accidentally picked the hold on, I'll just pause to do that properly. Okay, there you go. I managed to select that one properly. I'm rushing a little bit because I'm trying to get this finished before the 15 minutes is up. I'm going to show you how to mirror a part. We have to open up to find the plane that goes through that central hub. I'll put it at an angle, you'll see that. This is the mirror tool. You select the part that you want to mirror in the browser, which is extrusion 4. Then you select the mirror plane, which in this case is the YZ plane, and then we say OK. You can change the material to aluminium or whatever it is you want to put on your part, and of course save it. I would recommend saving as soon as you've made this central part and then update as you go. So after the other chamfers and fillets and things are put onto this part, it's finished, it's ready to put into the assembly.